What if I told you IPv6 devices can configure themselves without a DHCP server? Thanks to SLAAC and NDP, your network equipment is smarter than you think. But here's the catch. Without proper DHCPv6 setup, your devices might be missing critical DNS info. In this video, I'll reveal how IPv6 auto-configuration really works, when to use stateful versus stateless DHCPv6, and the hidden risks of relying solely on SLAAC. Stick around. This could save your next IPv6 deployment. IPv6 and IPv4 are very similar because we always need a unique address per host of a default gateway and a DNS server. The automatic configuration, which can be thought of as a mini DHCP server, is something new in IPv6, and some protocols have been removed or modified. Thanks to IPv6, our network equipment has much more power than in IPv4. IPv6 has been designed in such a way that everything is done automatically without the help of an administrator. IPv4 is used to discover the equipment on its network using the ARP protocol and broadcasting, and IPv6 uses the following protocols: NDP, ICMPv6, and multicast to discover the network. The NDP protocol has 4 functions. There is the solicitation of the router. As soon as a device connects to the network, it will first try to find a router, a gateway, or an exit to reach the outside world. It is a multicast packet which is sent to all routers. Following this, we have the announcement of the router. Our router will meet this demand by sending your local address. And we have the same functions for the neighbors. It works in a similar way to the ARP query. The PC will send a request asking for the MAC address of such and such an IP, and the equipment that recognizes itself will respond by sending its MAC address. The NDP protocol is therefore used for a number of tasks. It allows you to know all the IPv6 routers available in the subnet. It discovers the MAC addresses of the hosts it wants to communicate with. It helps prevent duplicate IP addresses by waiting for a period of time to make sure no other device uses the same address. This process is called DAD, and it allows you to know the IPv6 address as well as the network range, which the host will have to use. We will now talk about DHCP in IPv6. So as a reminder, each client workstation and each interface of our active equipment will have 2 types of IPv6 address: a global unicast address, which is routable, and a unique local address, which is not routable. Cisco routers use the EUI64 to create the interface ID, but some operating systems will use a random value. Thanks to the NDP protocol's SLAAC feature, the host will have a default IPv6 address and gateway, but one ingredient is missing. This is the DNS server. This function cannot help us find a DNS server. That's why we always need DHCP. DHCPv6 for IPv6 comes in 2 forms: stateful and stateless. The stateless form allows you to give the only information that is missing from the SLAAC function of the NDP protocol. That is, the IP addresses of the DNS servers. In a LAN network, the simplest way is to set up the auto configuration with a stateless DHCP server, NDP protocol, and SLAAC function. The DHCPv6 stateful works similarly to version 4. We still use it to give addresses, default gateways, DNS servers, and a few other options to customers. But one of the main differences is in the messages that are used. In IPv4, DHCP uses the messages discover, offer, request, and ACK. And in IPv6, it uses messages: solicit, advertise, request, and reply. The solicit message is similar to the discover message. The host will use this type of message when it looks up the IP address of the DHCPv6 server. The advertise message is used to give the host an IPv6 address, a default gateway, and a DNS server. The request message allows the host to ask if they are authorized to use this information, and a response is sent by the server to give its confirmation.